In this video, we begin our discussion on Chapter 11. In Chapter 11, our focus will be on learning some additional inferential techniques, which involves collecting two samples from two different populations and using the information extracted from those two samples to make deductions about the characteristics of those populations. In particular, you will learn that when we compare two populations, those two populations could either be dependent or independent populations. To get us started, we shall look at a couple of basics. And the first step is to differentiate between independent and dependent sampling. The best way to explain this will be to use a scenario to illustrate the difference between these two types of sampling techniques. The first example here reads as follows. Among competing acne medications, do you think or does one perform better than the other? In order to answer this question, researchers applied medication A to one part of the subject's face and medication B to a different part of the subject's face. So take note, in this case, we're talking about the same subject receiving two of those treatments. In order to determine the proportion of subjects whose acne cleared up for each medication, the part of the face that received medication A was randomly determined. What do you think? Does this scenario represent independent or dependent sampling? Justify your choice. If I were to answer this question, here is something I will note. The application of medication B to a different part of the same subject's face was based on the fact that medication A had been applied to one part of the subject's face. So, that is to say that I did not just choose any other random subject's face to apply medication B to. My goal was to compare the effect of medication A and medication B to a single person, or to see the effect of medication A and medication B on the face of one subject at a time, so that I can compare the efficacy of both types of medications. In other words, my choice of what part of a subject's face to apply to depends on the fact that I had already applied medication A to the same subject's face. This is a case of dependent sampling. So here we go with the justification. In print, the justification of the choice is as follows. The scenario painted here represents dependent sampling, which is also called match pair sampling, because once an individual subject is selected, one part of R or his face is matched up with the second part of the face. So we match different parts of the face to see the effects of the different medication types on the same face. This is, again, dependent sampling. Let's see an opposite scenario in this next example. Do individuals who make fast food purchases with a credit card tend to spend more than those who pay with cash? To answer this question, a marketing manager randomly selects 30 credit card receipts and 30 cash receipts to determine if the credit card receipts have a significantly higher dollar amount on average. What do you think? For me, I would argue that the selection of the 30 credit card receipts and the 30 cash receipts are definitely independent. In what sense? One individual person who makes a fast food purchase is not making 30 credit card receipts and at the same time making 30 cash receipts. That would be a waste. If that were the case, that would have been a match pair sampling. But since you have different people who make 30 credit card receipts chosen and different or possibly the same, 30 cash receipts made by randomly selected individuals again. These shows that these receipts have nothing to do with these receipts. So this would be a case of independent sampling. Independent sampling. Besides making this choice, we must justify our choice. So let's write the reason in print why this choice was so chosen. So the justification of the choice is as follows. In this scenario, the receipts selected from the credit card group have nothing at all to do with the receipts selected from the cash groups. So since it has nothing to do with the receipts, they have no connection, they are free, they are independent. In general, we say that a sampling method is independent when an individual selected from one sample does not have anything to do with the individual to be selected in the second sample. In contrast, a sampling method is dependent when an individual selected to be in one sample is also used to determine the individual to be selected in the second sample. Please note, dependent samples are also referred to as matched pair samples. And note that it is possible for an individual, in the case of dependent samples, to be matched against him or herself. Let's take some more examples on this, just to make sure that we bolster our confidence in understanding this concept. So, in this example, we are to determine whether the following sampling is dependent or independent. Indicate whether the response variable is a qualitative variable or a quantitative variable. This is the scenario. A researcher wishes to compare academic aptitudes of brothers and sisters. So she obtains a random sample of 140 pairs of siblings who take an academic aptitude test and determines each sibling's academic aptitude. What do you think? Do you think this sampling is dependent or independent? For me, here is what I think. I believe first that the sampling is dependent. Why? This is because if a brother is selected to be in one sample, then this selection automatically dictates that we have to select a sibling sister to be in the other sample in order to be able to compare the academic aptitudes of brothers and sisters. And in this case, the variable that is the response variable that is being measured is the academic aptitudes of brothers and sisters. And this variable is definitely qualitative because it classifies the individual. We move on to the next example. In this example, we are to determine again whether the following sampling is dependent or independent. Indicate whether the response variable is qualitative or quantitative. A researcher wishes to compare personality types of various married lawyers and their spouses. So she obtains a random sample of 919 such couples who take a personality inventory and determines each spouse's personality type. Remember, our goal is to determine whether the following sampling is dependent or independent and to further indicate whether the response variable is qualitative or quantitative. Here, the sampling is dependent again. Take note that we're about to compare personality types of married lawyers and their spouses. So, one population is the population of married lawyers, and another population is their respective spouses. So, whatever sample you select for this population or out of this population is dependent on the individuals you selected to be in the first sample of married lawyers. So again, just to note or to emphasize, the sampling is dependent again because an individual selected for one sample of married lawyers does dictate which respective spouses will be selected in the second sample. Again, here again, the response variable, which we want to measure, that is personality types is a categorical or qualitative variable because it classifies the individual.